one of the really nice things about some of this initial work is they did some pretty extensive evaluation. They would take a whole bunch of images and they would they would rotate them, they would scale them, stretch them, change the brightness, contrast, and add noise. And then the feature point descriptors would get run on the original image and the transformed, the distorted image. And then what you could do is you could say, under some matching criteria, how often does this descriptor, how often is its best match in this whole other image the correct one? The correct one being actually comes from the same point on the same object in two different images. And that's what they evaluated. So here's the first graph that I'll show you. Again, the error measure is the correct nearest descriptor percentage. How often is the one that matches best the correct one? All right? And then they varied a couple of things. The first thing that's easiest to see here is this number n. This was the number of those of the histogram that get used. Remember I said I was showing you only a 2x2, but they actually used a 4x4? Well, one of the reasons they used a 4x4 is a 2x2 is here, a 3x3 is there, a 4x4 is here, and all of a sudden you're sort of maxing out. So it looked like 4x4 was a good thing to use. By the way, this was evaluated by looking at a bunch of images and 40,000 key point descriptors, a bunch of images. So they looked at 40,000 different descriptors and the corresponding other image with all those perturbations. And so it's pretty serious evaluation. The other thing that's shown here is how many orientations in the bins, right? How many orientations in the histogram, how many bins? So you could have used just 4, you could have used 8, you could have used 16. Well, what you can see here is 4 does that. When you go up to 8, it gets much better. When you went to 16, you didn't do very much better than 8. So they picked 8. All right, so this was an empirically motivated set of parameters. Without going into too much detail, they also showed this is as they add image noise to the picture, how much percentage of pixels get noise or the magnitude of the noise. And you can see that the correctly matched value, again, falls off nice and gracefully, which is what you're looking for. You're looking for it slowly. By the way, going back to this previous one, you know, it's only getting up to like 50% match. We don't need everything to be matched correctly. We need enough of them to be matched correctly. And we'll assume the ones that don't match are all voting for Santa Claus, Mickey Mouse, and Donald Duck, if you remember that analogy, right? The ones that don't match sort of arbitrarily. So as long as we get ones that match well, then we're doing okay.